Alright, welcome to my video on simplifying exponents. You're going to need a piece of paper and something to write with. Take some good notes for yourself. At the end of this short video, there's going to be some homework problems that are due next class. So the topic again we're looking at today is simplifying exponents. The directions will say simplify completely. If you notice in the problem, there is no equal sign, so there should be no equal sign in your answer. We start off with x squared plus x cubed, and right away that's already simplified. And the reason why is because you have to have the same base and the same exponent in order to add or subtract like terms. So that one is already simplified. As we move to the next one, x to the fifth plus x to the fifth, we do have like bases. In this case, the x, and we have like exponents, the 5s. And so we're going to add the coefficients. We don't see anything there, so I'm going to assume they're 1s. And we get 2x. And when you add, you keep the exponent the same. So we've got a rule there for you. If the bases are the same, we're going to add the coefficients, but keep the exponents the same. Moving on, I'm going to let you take a stab at this one. We've got 5x to the fourth plus 3x squared plus 6x squared. Go ahead and press pause and try this on your own. Alright, welcome back. Hopefully you noticed 5x to the fourth did not have another term that was a like term. So we are just going to simply add 3x squared and 6x squared. Again, we add the coefficients, leave exponents as they are. If you got that one right, give yourself a nice pat on the back. Moving on, we're looking at what to do when you are multiplying like bases. When we multiply like bases, we just simply add the exponents. So x to the fifth times x squared. 5 plus 2 gets me 7. So we're left with x to the seventh. There's your rule. Moving on, we are multiplying again. This time we have some coefficients in front. And we're going to treat coefficients like we normally would. I have 3 times 4. So that simply gets me 12. The y's I have like bases, so I add their exponents. 4 plus 3 gets me 7. So 12y to the seventh is the final answer. And we're just going to talk a little bit about coefficients. So when there are some coefficients, multiply them, but still add the exponents. Number 6. We've got x to the seventh over x cubed. We are dividing like bases, and when you divide like bases, you subtract the exponents. 7 minus 3 gets us 4. So our answer is x to the fourth. So again, dividing like bases, subtracting exponents. Let's talk about coefficients. 24 x to the ninth divided by 6x to the fourth. We're going to just divide the coefficients. 24 and 6, that gets us 4. And again, we're dividing x to the ninth and x to the fourth. Subtract their exponents. We end up with 4x to the fifth. So when you have some coefficients, you will divide them, but again, still subtracting the exponents. Now you try this one on your own. Please hit pause. Welcome back. This one had a little challenge to it in that 12x to the fifth y to the seventh wasn't already a fraction. We go ahead and make that a fraction by putting it over 1. When we multiply fractions, we multiply the two numerators together. So we'll do that right now. 2 times 12 gets us 24. X to the sixth times x to the fifth. We add those exponents. And y to the seventh. And on the bottom, we multiply 3y to the fourth times 1, which is just 3y to the fourth. Now we can go ahead and take care of 24 divided by 3 is 8. X to the 11th doesn't have a like term. Y to the seventh divided by y to the fourth is y to the third power. If you got that one right, give yourself a second pat on the back. x to the 5th raised to the 9th power. This is raising a power to a power. And when we're raising a power to a power, we are going to multiply the exponents. So 5 times 9 gets us 45. So this is x to the 45th power. Our rule, when you're raising a power to a power, we multiply the exponents. Number 10 and number 11, we have some multiplication in number 10, namely x to the 4th times y to the 3rd, and that's raised to the 8th power. And in number 11, we have division, x squared divided by y to the 4th, and all of that is raised to the 6th power. In this case, and going back to 10 here, we're going to raise all the bases to the 8th power. So x to the 4th is raised to the 8th power. We raise a power to a power. We multiply them. 4 times 8 is 32. But 8 also goes to y cubed. And again, when we raise y cubed to the 8th power, we multiply and we get y to the 24th. In number 11, again, the raising to the 6th power is going to happen to both x squared and y to the 4th. We multiply the exponents. So we get x to the 12th over y to the 24th. And here is our rule. When there's multiplication or division of bases raised to a common exponent, all bases are going to get raised to that exponent. Moving on, we have x to the 9th over x to the 9th. Well, we've learned that when we are dividing, we subtract exponents. In this case, 9 minus 9 gets us 0. And what do we do with that? Well, what I want you to think about is x to the 9th over x to the 9th. What you have in the numerator is the same as what you have in the denominator. And I want you to think about, well, what would 4 over 4 get you? I think that gets us 1. And that's going to be true anytime whatever's in the numerator matches what's in the denominator, unless it's 0. In this case, we have x to the 0 power, but we had x to the 9th over x to the 9th. The same thing was in numerator and denominator, so your final answer will be 1. So anything other than 0 to the 0 power is always 1. Moving on, we have x to the 3rd divided by x to the 5th. And again, when we're dividing, we will subtract the exponents. When we do that, we get x to the negative 2nd. 3 minus 5 gets us a negative 2. We are not allowed to have negative exponents in our answer. So what I want you to do is think about what x cubed means. X cubed means x times x times x. And on the bottom, you have x to the 5th. So that's x times x times x times x times x. And then we'll think about, well, what's x divided by x? We've talked about that. That's 1. X divided by x is 1. X divided by x is 1. So when you simplify that, we have a 1 on top, and we have x to the 1st times x to the 1st. When you multiply, we add the exponents, so we get 1 over x squared. So comparing our original x to the negative 2nd to now 1 over x to the 2nd, we can see that x to the negative 2nd was moved from the numerator down to the denominator, and the exponent became a positive 2. So our rule for negative exponents, you're going to move the base with the exponent. In this case, it was in the numerator. We moved it to the denominator, but you know, again, if the negative exponent is in the denominator, we'll move it up to the numerator with the base and make the exponent positive. One last problem for you to try on your own. Please go ahead and hit pause and try this on your own. Welcome back. Hopefully you took 4 divided by 6 and reduced it to 2/3. X to the 3rd divided by x to the 4th. When I subtract those exponents, I get x to the negative 1st. Y to the 8th divided by y to the 3rd gets us y to the 5th. And then finally, z to the 14th divided by z to the 14th is z to the 0 power. Do a little more simplifying here. 2 and 3 helps us create a numerator and denominator. X to the negative first power can't have negative exponents. We will move that down to the denominator and make the exponent positive. I'm not going to write an exponent in there because we assume that there is a positive 1 on that. Y to the 5th stays in the numerator, and then z to the 0 power, that actually equals 1 all on its own, and 1 times 2y to the 5th over 3x is just simply 2y to the 5th over 3x. If you got that third one right, give yourself a third pat on the back. What you're going to do now is complete the homework problems that follow. Please copy them down on a piece of paper and complete them with any necessary work. You can go ahead and hit pause and write these down. Good luck with your homework. I hope this video helped you. Thanks for watching.